Hi, and welcome to another tutorial video. In this tutorial video, what I'm going to be doing is going through the adjacency list, and this is one way that we can implement a graph in software, so how we can represent a graph in software. So, how does an adjacency list work? Well, an adjacency list works by maintaining a record for each node which holds the nodes that it has a connection with. So let's have a look at some examples of how we can construct adjacency lists from graphs. Okay, so I've got an example of a graph here. It's unweighted and it's undirected. And now over here, what I'm going to be doing is showing you how to construct an adjacency list. So this is the start of our adjacency list, just a bit like any other table you might draw. And what we're going to do in this node column here is write down a record in our adjacency list for each node that we've got in the graph. So I'm going to write down A, B, C, and D. Then what I'm going to do in this adjacent nodes column is write down for each node which nodes are adjacent to that node. So for example, for A, what I'm going to do is write down B and C, just like that. Then I do the same for all of the other nodes. So for B I do A and D, for C I do A and D, and for D I do B and C. So that is our adjacency list, and it's as simple as that. It's just a list which shows all of the nodes in our graph and which nodes they're adjacent to. Okay, so now I've made my graph a directed graph. So what we need to do is modify our adjacency list to reflect the fact that the graph is now directed. So if we look at A now only has a connection to B. A is now only adjacent to B. So we write down B in here. B is not adjacent to any nodes because it has no arc coming out of B that is directed to another node. So we don't put anything in the B row. C is now only adjacent to A, so we just write A in the C row. And D is still adjacent to B and C, so we write down B and C here. So as you can see now, we've reduced the number of nodes we're writing down in the adjacent nodes column, and that is because we've made the graph directed, so the nodes in our graph aren't connected to, are adjacent to as many nodes as they were before. Okay, so now what I've done is I've added some weights to my directed graph, and the way we represent this in the adjacency list is by writing the nodes as key value pairs. And if you've studied dictionaries before, you may well be familiar with what a key value pair looks like. And indeed, when we're implementing a adjacency list, we can store for a weighted graph, the adjacent nodes for any particular node as a dictionary or hash map, or we call something different in whatever language you're using probably. So let's just go through an example of what that looks like. So A is connected to B, and the cost associated with moving between A and B is 6. So we write down a key value pair here of B and 6, and imagine that we're storing this adjacent nodes to A as a dictionary of key value pairs, and in those key value pairs we've got the node and the weight associated with going from A to that node. So for the node C, the node C is adjacent to A, so you write down A and 2 like that in a dictionary-like structure. And for D, we do the same thing, so we write down B, and then the cost associated from going from D to B is 7, Then we do a comma, and then we do the same for C. So the cost associated from going from D to C is 3, and then we close off our dictionary. So that's how you would represent a weighted graph in a adjacency list. Okay, so let's go through a further example here, just so we make sure we understand what an adjacency list is. So here, what we've got is a unweighted directed graph, and let's just go through and fill out this adjacency list here. So the node A is adjacent to E. You put that in there, and that's the only node it's adjacent to. That's the same for the node B, and the node C, and the node D. And the node E is not adjacent to any other node, so we leave that blank. So that's our basic adjacency list. Whenever a graph is unweighted, all you're doing with an adjacency list is you're looking at what node you've got on the left-hand column here, and looking at your graph and saying, okay, what nodes are adjacent to this node in my graph? In this case, for A, it's only E. Okay, so now I've added some weights to my graph, and all we're doing, again, with a weighted graph in an adjacency list, is we're storing as a key value pair the node that the node on the left hand side of the list is adjacent to. So in this case with A, we're saying that A is adjacent to E, and the cost associated with moving from A to E is 2. So we're storing that there as a key value pair. And then we do the same for B. So the cost associated with moving from B to E is 10. From C to E, that cost is 3. And from D to E, that cost is 4. So we're storing in our key value pair the node that this node on the left hand side is adjacent to, and the cost associated with moving from the node on the left hand side of the adjacency list to this node here. And as I showed you in the previous example, if you've got multiple nodes that the node on the left hand side is adjacent to, you can do something like this. So you just say for example, my node was A that this node on the left hand side is adjacent to. Write down the cost, say for example 7, then do a comma, then write down the next node that it's adjacent to, write down the cost, then do a comma, and then so on. Okay, so that is 2 examples of how to use an adjacency list to represent a graph. So I hope you found this tutorial video useful, and thanks for watching.